that will be issued in 2021 as part of an Arctic Council working group. So shout out to CJ for developing that. Now, in the professional associations for fire, the importance of people and developing human capital has really come to the forefront. There are two associations that most scientists in wildland fire will be a part of. They are the Association for Fire Ecology, but also the International Association in Wildland Fire. This is just within the last month. Both associations have been trying to offer not just diversity training and inclusion or equity, but really thinking about how do we understand and how do we effectively manage fire across all landscapes. And what that means is that you have to understand all communities. And so you see now a push in our wildland fire science associations, which is akin to what we're seeing in our geospatial organizations as well. This understanding of our human capital, because we are the drivers, right? Computers are not smart, they are obedient. And so we need to understand the intelligence and capital of the people who work in fire science, as well as in geospatial science. And to that point, this summer, with very little prodding from their group members, and these are memberships that are global, both the IAWF and the AFE issued a joint anti-racist statement. Because I do think maybe that most people don't know that wildland firefighters are not just white men, right? Wildland firefighters draw from the communities that they're a part of. There are many African American, Black, Latino, Hispanic, Asian American, and a lot of women who are wildland firefighters. And in our science, we are diverse as well. And so that's important, for our community to think about that, but to know that even in this, maybe traditionally male-dominated field, we are seeing a change. And so what's driving that change? Well, let's think about how does one actually get into geospatial science, right? Because that's hard. Like, how did I end up here as someone who was just good at GIS classes, but also interested in fire? Well, there's many pathways to that. You can come from a GIS, geospatial, and Earth observations perspective. Maybe the data excites you, the science behind it. A lot of people end up here because they started out as wildland firefighters or working for forest services, state-level agencies, parks management, or Department of Interior. And then, of course, you can also do this through community planning, as we've come to understand now that wildland-urban interfaces, sometimes called the WUI, and other community management will have to adapt to a changing climate and also a growing population, just as we have had to adapt, right, to COVID-19. Now, how did I get into this? Well, I got lucky, basically. When I was at Morehead State, a professor of mine, who is now actually a colleague of mine at Miami University, took me in as his research intern. And because I was local, because I grew up in the forest, I was able to serve as a local traditional knowledge of an ecosystem. And I helped create a fire risk model for southern pine beetle infestation for the red bird or southern district of the Daniel Boone National Forest. And from there, because I had real world experience, I was able to compete for and obtain a research scholarship to the University of Maryland, which I would never have been able to go to graduate school without a scholarship, particularly not in Washington, D.C. So that's how I got into this field. It was kismet. It really, there was no planning or foresight on my end. So what am I doing now? Well, I'm still actually out there lighting fires. So I want to talk a little bit about how I'm able to do that, right? So maybe I look at satellite data most days, but in order for me to get out in the field, and I mean globally, I've helped plan field campaigns from Russia to Ethiopia, and here in the United States and also parts of Canada. And the way I do that is I have to create relationships with stakeholders who are working on the landscapes. And so, for example, I want to talk about the NOAA-NASA Fire XAQ field campaign that we completed in summer of 2019. Now, following along with some hot memes going around social media. Now, how did this start? Well, it started as a graduate student. So on the left, you'll see a photo of me as a master's student, actually helping sugarcane farmers set fires to their field in Louisiana, when we knew that the MODIS satellite would be overhead. And I'm carrying an old Trimble GPS unit in my hand, as you can see. And that's me in 2004. And how's it going? Well, by 2019, I was one of the field leads to direct the DC-8, a $1 billion experimental plane that's run by NASA and NOAA, to fly through smoke plumes. So I was part of that leadership of mission control. And it took, I'm not kidding, those 15 years to develop the relationships needed to do this kind of stakeholder engagement. And how did I do that? Well, you have to communicate and engage. You start early. For my case, I started many of these relationships as a master's student, and just cultivated them over the decade and a half. But also for this particular field campaign, I turned to my expert knowledge holders in these regions, particularly Dr. Carol Baldwin, who runs the Great Plains Fire Science Exchange, and Mr. McCree Anderson, who runs the Arkansas Prescribed Fire Council, and it works at the Nature Conservancy. And in both cases, I let them know 2-3 years in advance that we would be doing this. We met face to face. I would travel to see them. And then during the field campaign, I made sure to make stops to engage with them one-on-one, and then communicated with them on a daily basis as we drove around the Southern Great Plains and the Mississippi Delta to direct this DC-8 to fly through smoke plumes. And then there's follow through. And I can't be adamant enough about this. If you're someone who wants to work at that intersection of science and stakeholder engagement, you have to give credit where credit is due. I am not necessarily an expert in Great Plains fire regimes. I know more than the average person. But when I want to learn more about that, or to cultivate a research project on that, I work directly with Dr. Baldwin, and I include her in those projects. And I give credit to her knowledge. And I continue this active collaboration, which I think is funny. We were joking about text messages, but no joke. When people email you, email them back. When people invite you to a talk they're giving, try to attend at least a part of it. And you know, in pre-COVID and in post-COVID times, buy them a coffee. If they drink alcohol, buy them an adult beverage. Spend time getting to know them on a personal level and on a science level. And that's how you do this. And most of all, think of expansion rather than contraction. In our group, which is actually led by Dr. Amber Soya, who is one of the founding women in fire science in the US for satellite data analysis, you know, we try to expand our group and give credit to every student, including listed here graduate students Eileen and Tony Francis at Miami University, our postdocs like Dr. Liz Wiggins, and our early career analysts like Emily Gargolinsky, so that we know that, and the rest of the world knows that we are a team that wants to build and keep relationships going. So let's talk a little bit now about some science. I want to talk about a novel fire regime. So I am a U.S. representative to the Black Carbon and Methane Expert Group of the Arctic Monitoring and Assessment Program, which is a working group of the Arctic Council. The U.S. is one of 8 member states of the Arctic Council, and on this expert group, I serve as the expert for fire and fire emissions across the Pan-Arctic. Here is an example of a large wildfire that actually occurred about 79 kilometers from the Greenland ice sheet in 2017. This is the first recorded wildfire in Greenland's history of this size. There are, of course, smaller fires that had occurred, but this fire burned for a month. And so this is what really triggered my interest in Arctic fire regimes. And so I want to show you why you should be interested. The Arctic fire regimes still work on this same fire triangle. It's still about climate change, it's still about fuels, and it's still about people. What we know in the fire regime shifts in the Arctic is that they're burning earlier. They're even burning now before the ice has melted off some of the lakes and rivers. And they're burning later in the year. These are two examples using Sentinel-2 data where we have fires starting mid to late May while there's still ice and burning into middle of October, even into the end of October, stopping only as snow falls. These extended fire seasons mean that we have extended fire intensity using some combination of understanding fire activity and fire regimes with global climate change models. What we're seeing are estimates of fires in our high northern latitudes, so think above 50 degrees north, of 20 to 50 days. And in our boreal systems, what we're seeing are predictions of almost a month of crown fire potential. And crown fires in the boreal system are basically unmanageable. So by the mid-century, that's only 30 years away, we could be seeing a whole month of uncontrollable fires. How do we go about predicting Arctic fire regimes? Well, one of the things that has come out, and again, like we need knowledge from lots of people to understand this, is that in the phenomenon of the Arctic oscillation, which is how Arctic air moves around the Pan-Arctic, we have found a relationship between the Arctic oscillation and increased fire activity, particularly in Siberia and Far East Russia, which means that extreme fire years, as documented in, say, 2016, actually correlated with a positive Arctic oscillation. Now, we can predict positive Arctic oscillations. This is a recent paper that shows that Arctic oscillations, whether they're positive or negative, that directional category is defined by the middle of January, so kind of like the dead of winter. Using a multi-model approach, which involves 6 different regional climate and weather models, you are able to predict that with a 40 time. That means you can predict an Arctic oscillation the 1st of December before it actually occurs in the middle of January. And that then gives countries, agencies, right, wildland firefighting units, time to plan then for a potential extreme fire season summer. And what can be managed? Well, I mean, this is where it's actually, you know, up to us, literally. We can't change the weather and we can't modify lightning activity. So we can reduce human-caused ignitions and we might be by fuels, okay? So let's talk about how we can modify fuels. Well, this is complicated in the Arctic because it's not necessarily trees. It's different when we think about wildfire regimes in forested areas. I mean, even at the base of my work, right, thinking about southern Appalachian forest, mixed mesophytic hardwood forest with plateaus of native grasslands. Those fire return intervals are 25 to 30 years. That means in a human life, you may see a wildland fire twice. In the Arctic, we're not really talking about biomass of that quantity. In fact, we may be talking more about peat. And then as permafrost thaws, even more ground level fuels. So this is more complicated in understanding what fuels are available. And there is a focus on people because the Pan-Arctic is populated, or I would say 1/3 of the population of the Pan-Arctic are indigenous peoples who have lived there, right, before anyone. And so they understand the landscape better. But the people who are living in the Arctic also need advanced and more economic development. It is a difficult place to live, and they need more access to markets. But those economic activities are actually fire risks: timber extraction, peat extraction, energy production, and tourism. In fact, both wildland fires in Greenland in 2017 and 2019 were caused by tourist activity. So it is this push and pull and need to develop, but also an understanding that these landscapes that we thought were fire resistant are actually now fire prone. There's also this idea of holdover fires, sometimes called zombie fires, and that just means fires that burn into this peat, this high carbon soil, and then overwinter because the snow acts as an insulation blanket, like literally a blanket keeping it warm so it can burn throughout the winter, and then pops up again the next spring. And those are really hard to map and to understand. And then, of course, we'll talk a little bit then at the end about what can we do about wildland firefighting policy and infrastructure, and then, of course, management of human-caused ignitions. So let's start with the fuels. Some recent work that came out of Nature Climate Change showed that in the boreal zone, so that's just below the Arctic, that fuel availability and actually not fire weather are what really control severity and peat emissions, as well as tree biomass consumption during fires. So understanding what fuels are there and how we manage them is important. This is work that that I published with colleagues at CU Boulder, INSTAR, Dr. Merritt Turetsky, and also Dr. Thomas Smith at the London School of Economics, where we showed that the new Arctic fire regime should actually now focus on more of our Arctic landscapes and ecosystems. And so, because we're seeing fires now in essentially landscapes that people thought would not burn. And we're able to document that using geospatial software and Earth observation data. Of course, mapping Arctic fires will require a real challenge for the geospatial industry. Satellite-based observations underestimate open burning caused by humans in agricultural landscapes and rangelands. Surface fires in boreal forests are hard to see because you can't see through the canopy. And then, of course, smoldering peat fires. And so, satellites won't be the only solution. We will need to combine this with more complex GIS models, geospatial understanding, and even network analysis of human activity. And with a warming climate, there is a risk of increasing peatland or legacy carbon fires. And we don't really have a good scientific grasp of what that means for the Arctic. And just so you know, some recent data that came out last month shows that about half of all northern peatland carbon is presently classified and is presently stored in soils that we would classify as permafrost, right? Because permafrost is not a soil type, it's a condition of soil. And in the northern hemisphere, peatland as an area is about the same surface area as the country of India. So this is a large potential source for fires. How would we manage these new Arctic fire regimes, right? So I think one of the powers of GIS and geospatial analysis is that we can actually combine different systems and different scales, both spatial and temporal. Some challenges to consider. Some work led by the Canadian Natural Resources and Forest Service agencies found that as fire intensity increases in the boreal and then the transition from boreal to Arctic, that our human capacity to fight them as wildland firefighters goes down. At 2 megawatts per meter, you see ground resources need aerial support. At 4 megawatts, I think really like fire power, aerial suppression via air tankers is no longer effective. And then at 10 megawatts, even heavy air tankers. So think of those planes you've seen drop that like red liquid, the fire retardant. They're no longer effective and cannot suppress a fire line. And so, this has real implication thinking about how we would fight wildland fires in the boreal and the transition from boreal to Arctic. And note that by end of century, there'll be a 1 in 4 chance of large tundra fires in Alaska, where we don't want to use necessarily the same wildland firefighting techniques because permafrost is so fragile, and we don't want to dig, and we don't want to use the normal mop-up techniques from wildland firefighting. And so this will be a challenge to adapt to. And of course, we have a hard time understanding and also managing human-caused ignitions. This summer was an extreme fire season in parts of Siberia and Far East Russia. We actually don't know how most of the fires started because there wasn't enough lightning activity to be the ignition for all the fires. And so a lot of these will be officially ranked in statistics kept by the Russian government, which are very good and go back many decades, as unknown because it will be hard to understand who's causing these fires. And so there is a real need for geospatial understanding and mapping of human-caused ignitions in this new fire regime. Right. So now that we've learned a little bit about science, I want to come back to the title of this talk. So when I was asked to give this talk, particularly they wanted me to talk about my experience, I think, working in fairly male-dominated industry. So while I work at the intersection of fire and food, which really means I work in wildland fire and agriculture, like, how do I do that? Well, my career fire triangle is really thinking about things in terms of ambition, skill, and opportunity. So for ambition, there's really no one mold to follow. I was thinking about this morning. I know lots of very successful scientists, practitioners, even science policymakers, and they have all kinds of different personal lives and family histories. They come from different socioeconomic backgrounds. We're not all the same ethnicities and races, and we definitely aren't the same religions. um, and and so I would just say, whatever ambition you have, there's no mold that you need to follow. You don't need to be a particular type of person. I would just maybe follow some, simple advice that that my older brother always tells me, which is, you better brag on yourself because ain't nobody else going to do it for you. All right. So go ahead and strive for ambition. Say yes, but learn to say no when you can't do it. Now, skills are really important, and I think that this daily or today's talks are really focusing on that, and that's important. Just so you know, I code in R, basic Python, JavaScript. I know Esri, QGIS, Imagine, Envy. I have basic understanding of MATLAB that I used to have to work in. I can interact with Unix systems and AWS servers, and I've had to talk to NASA supercomputers before. And so how do I do this? Well, I just keep my skills up to date as much as possible. As a professor, I think that's easier because I have to teach other people, which means I have to be good enough to teach them. But, I set a goal. This month, I'm doing the 30-day map challenge, and I'm making all of my maps in open source software. So no Esri products. And 2 years ago, I decided that I was going to teach a class in one semester in ArcGIS Pro and the next semester in QGIS. And that made me learn both softwares and learn the pluses and minuses of both. So really think about the skills you have and bring them to the table. And don't be afraid to volunteer to improve your skills or demonstrate them. And of course, with opportunities, I would just say yes to opportunities when you can. But if you feel like you're not the right candidate, don't just say no, offer up a different candidate. Really try to elevate other people you know in the industry, or maybe colleagues or fellow students who you know aren't getting the same chances but would be a really great candidate for that opportunity. And honestly, I have clients come back to me, particularly international clients, who want to work with me because, and when I could not do the work for them or did not think I was the right candidate, I pointed them in the right direction to the right group. And they find that that network that I've built of just knowing people is valuable to them. So say yes to your opportunities, be ambitious, develop your skills, and elevate others. And then finally, I will just note, last year I showed this picture in my class, and all of my students, no matter if they were male, female, they said the same thing to me. They said, "You're the only woman in that photo." And I said, "Yeah." And it hadn't really dawned on me, but much of my professional life, I am basically the only woman in the room. And so when I can, I try to build field teams where it's just women. I have field sites on Kilauea on the Big Island of Hawaii, and my field sites were really crewed by myself and 2 other scientists, and we still go back and visit them when we can. I am an expert in agriculture and fire, and so when the UN needed me to step in to go to Punjab last fall, I am familiar enough with my colleagues that I felt safe doing that alone. And again, I would be the only woman at some of these kind of upper level tables during discussions, but that's okay. I would just say you are the only you in the room, and that's an important person, and be that person, because I bet that's who the people in the room need. And with that, I'd like to just end and take questions, or allow the esteemed moderators to move on to the next speaker. Thank you.
Well, thank you so much, Jessica. That was fascinating. I actually put an article from Wired that I read just a few days ago about utilizing math to combat zombie fires in peat in the Arctic. So I think this is very timely. We've got a lot of comments saying great presentation, great talk. And I really was touched by what you said about you're the only you in the room, and nobody else is going to be promoting you the way that you need to be promoting yourself. When you get up and look in the mirror at yourself in the morning, you're the only person that you have to answer to, but you're also the only person being your champion. And so I know that, especially in the United States, especially for women of color, it is very difficult to learn that it's okay to speak up, that false modesty is not false modesty, it's just shooting yourself in the foot professionally. And it's okay to ask for more responsibility, for more pay for less responsibility. If you can come at it with a data-driven approach of this is what my value is, and this is why it's so important. I really appreciate that you were able to bring sort of a different perspective. Like I do GIS as a consultant professionally for municipalities, and so to be able to see research and to see a woman using R, I really appreciated that. A lot of things about inspiring. Somebody said, great presentation, Dr. McCarty. How do you translate functions and features between all of those GIS applications? Because Esri terminology differs so greatly from QGIS and other open source.
Oh yeah, that's a really great question. So I will just say that we often, when I start a project, so right now I have a research scientist that I pay on my grants and contracts, and graduate students and undergraduate researchers, all paid to work on my projects. I do believe in everyone being paid for their time, because I could not have afforded to be in this industry if someone hadn't paid me. So I return that favor. So that's a really great question. So here's what we do. We start a kind of README document at the beginning of each project. And in it, we know that, okay, some of this is going to be done in R. And then we really document the code as much as possible. If it's done in Google Earth Engine, we document that as much as possible, and then try to archive it. You can archive your code. And then when we need to go back and forth between ArcGIS and QGIS, we do create like a FAQ for our methodology. So when we write up our papers or annual reports, we have those methodologies ready to go. We make sure that we list the exact steps that we did in QGIS. And then honestly, to be quite frank, we can do most of it now in QGIS, but not all. Esri still does some things better. And so when we need to take it into Esri, we document the exact steps and the names, the terminology, right? The nomenclature, so to speak, so that we can come back to it. And then in my classes, when I show things in R or Python or QGIS and ArcGIS, I will actually list their different names for students, because it is really important that you understand that oftentimes people are saying the same dang thing. That's just, they're using a different word for it. And so that's important. I do work a lot in Europe. And so QGIS was initially developed by European coders. And so I had to learn that terminology. But now that I know it, I just kind of go back and forth. And to be quite frank, because a lot of the work I do is international, I have projects right now in Vietnam, in West Africa, in Peru, in Colombia, in Russia, the Arctic, and I have to use open source because I just can't guarantee that they have access to Esri. But that does not mean that I don't use Esri. Of course, I still have to use Esri for certain things. So yeah, I guess that's how I would do it. I'm a big proponent of documentation and just taking notes, right? It's better to have a short pencil than a long memory. And I just try to implement that in my work life as well. If I could, I would turn my camera around, but I actually just have a bunch of Post-it notes at my work office, plus the art that my 4-year-old makes for me. So it's a good mix of the two things. So, and the other thing I would do is, I'll show this, but I actually hand draw a lot of maps before I do them. So this is the Pan-Arctic, thinking about fire. And then once I know what I want it to look like, it's easier for me then to pick the software that I want to do the analysis, because I know that QGIS can do that analysis and make it look nice, but I also know that Esri might have better templates to store it to share with other partners. And so I kind of think about that. And yeah, I agree with what Andrew said. It does go along with what Kelly said earlier, like document everything. And to be quite frank, don't be a snob. Like if Excel does it and that's what your client wants, do it in Excel. There's no reason to make them learn R just because you want to show that you can code in R. Yeah.
So one of the things I'm curious about is, are you familiar with Dawn Wright at Esri? She's, I believe, the lead scientist. So I'm curious, I know that Esri wants to be at the bleeding edge, the rip-roaring bleeding edge of all GIS technology. And I'm curious if you had considered maybe approaching her with some of the challenges that you face working in an international environment, and how Esri might be able to better coordinate with QGIS and other open source GIS in order to be able to better share data across multiple platforms.
That's really interesting. I guess I see myself more as a academic, often like a U.S. representative to international groups, and so I think like maybe I shouldn't get involved in this, like in these turf wars, in a way. And so, but I would say that Dawn Wright, she has a PhD in oceanography. Like she's a well-known scientist in her own right, not just in geospatial science. And this is a big shout out to her. About 5 years ago, a dear friend of mine from graduate school, who was working as the only cartographer at the State Department, the U.S. Department of State, he passed away from stomach cancer, and we started an endowed scholarship in his name at the University of Maryland. Dawn read about it somewhere, and she donated to it because she just thought that it was a good scholarship to have in his memory. And so I also just she's a really nice person, and she really is here to develop the industry. And I hope people remember that about her, because yeah, she's a great addition to our community.
She is, and I think that especially with the emphasis that you're making on and making sure that your work is inclusionary to a number of diverse groups, I think that she would definitely be a good person to have in your corner. So I highly recommend reaching out. She's very open to discussing things, especially with other female scientists. All
right. Well, I'll think about that. I appreciate that, Kelly. And I'll turn it over. I want to hear what Robin has